First of all, let's double check if you can see my terminal well. Is it big enough? Bigger, oh no. Okay. So, hello, my name is Bartek. I work in London as a software engineer at a company called Improbable. I work in a kind of small team around observability. Our focus is, the 4 swim lanes, let's say, so metric logging, tracing, and tracking. I love Golang. I love working with open source community. Love, distributed systems. So I maintain several projects as well, including Thanos, which we started 1 year ago and is already used by several companies on production. And yeah, it is helping those companies to run Prometheus at scale. So the idea for this talk came from the fact that Thanos, that the seamless integration with Prometheus and kind of easy gradual deployment model is like where Thanos stands out from other solutions. So I thought, well, if I can, transform vanilla Prometheus into Thanos in like 15 minutes on stage live, then it must be easy, right? Kind of. So that's why I'm here. And this talk is like full demo live on my laptop using 2 VMs on Minikube, 2 virtual, 2 Kubernetes clusters. And I will try to explain Thanos concepts and transformation step by step. So let's not waste time and let's get into the action. Cool. So we'll start with explaining the initial setup we have. As I mentioned earlier, everything is happening on my laptop. I have 2 VMs with 2 separate clusters, let's say. And we can see that each cluster, we have like EUS1 and EU1. They both have Prometheus replica that scrapes local targets only. And EU cluster is a bit special. It has Alert Manager for alert routing and Grafana for dashboards. And this is obviously a bit simplified, right, setup, because you might have, some VPN or peering between those 2 clusters, or you might have service mesh, or you might have more complicated Prometheus scenario like federated Prometheus, sharding, HA, or things like that. Still, the same Thanos transformation applies, so it's fine. So since we are in the GrafanaCon, and Grafana is like this entry point for our metrics, let's get there. Let's make it a bit bigger. So essentially what you can see is like a super simple dashboard, just 1 metric, and the metric is container memory usage bytes across containers. And that's our setup, right? You can see around our 2 different data sources from 2 different clusters, EU1, EUS1. All is fine. We have seen some data. EU1 has more services, so we can see some more details about that. So, yep, this is our setup, and my goal is to showcase the business that wants to operate multiple clusters and want to have like insights on the application metrics around that. Cool. So with that, like, do we see any issues? Like, we are running Prometheus at scale, right? We have more than 1 Prometheus right now. So it's working fine. So do we have any problem? Well, actually, we have 3 problems, and let's enumerate them. First problem is the fact that we are missing a global view. A global view is an ability to query, aggregate and operate on metrics from 2 different data sources, from 2 different Prometheus instances. So let's, for example, let's say I want to see, right now I can see Prometheus memory usage for just Europe, and I would like to know the total amount of memory used by all Prometheuses across all the clusters. So the naive approach would be like, okay, I would just, remove the cluster grouping. Here we go. Well, nothing happens because each Prometheus has only data from the local cluster itself. So we end up manually, the only way we can do it, we need to manually add the values from different data sources, or use cool like split feature and compare and manually add this. It's not convenient, right? And the reason is that we have those data available, but from different API endpoints. So it's not really easy to solve. So this is the first one, global view. Let's close Grafana for now and move to the second issue. Let's see what we have here. So as you can imagine, well, the second issue you might find here is that our Prometheus has pretty low availability because it's only one. And you can imagine like hardware error, configuration error, or simple rolling restart. So you want to apply some changes to Prometheus. It can all cause disruptions because we have one Prometheus, and if it's down, even for minutes, you are losing the data, you're losing the query availability. So one would say, well, it's easy to fix. We are in the Kubernetes world. Let's add another replica, right? So I will use, yeah, I will just do that. I will use my magic command to like auto-generate the metrics for 6 hours and add another Prometheus. Let's check how what we need to change in the Prometheus YAML to achieve that. We are adding just a special service, Kubernetes service, to access each replica separately for convenience. And we are adding another replica to the counter. So let's apply this. And once it is up, before that, let's also make sure that Grafana has access to this, right? So we are just adding another data source. Now, once Grafana is up, we should be able to use our HA data, right? Like, it should be perfect. So let's see. Cool. So what you can see now is that without global view, we don't actually have ability to use this data, to use our multi-replica setup easily, because now you need to like pick data source manually, and if you have gaps in the different places in different replicas, just choosing a proper one like manually is like it's not well, that does not work well, right? And you can imagine like people try to solve this issue by putting a load balancer to those replicas, and it's not solving the problem as well, because those gaps, whatever you choose, whatever replica you choose that is available, it has these gaps in a old metric data. So you need something smarter, some seamless HA support. So that's the issue number 2. And the last one is retention. Let's see how much data we have. So we have like roughly 2 weeks, and it's not because I auto-generated 2 weeks. The retention is actually configured as 2 weeks, and making it longer is quite complicated. Well, you can increase the flag, but the local storage is super expensive to operate. Think about operations like resize, backup, and it gets quite expensive. So preferably, I would like to see years of the data for long-time characteristic. And the one last missing bit is downsampling. Without downsampling, you cannot query for 1 year of data, because it will simply kill your browser, and not Prometheus anymore, because we added like max number of samples we can get, but it will reject your query. So yeah, that's our missing bits. Cool. So we know about the problems, and essentially Thanos was designed to solve exactly those 3 goals. Yeah, let's start our transformation then. And the transformation is split into 2 phases. First of all, we will fix global view and HA, and as the last item, we will fix limited retention. So step number 1, add a Thanos sidecar. So Thanos sidecar is a simple binary you add to the Prometheus YAML. Let's see how Prometheus YAML needs to be changed. So first of all, we are adding special Kubernetes service for gRPC traffic. It's because sidecar exposes a gRPC API called store API, and actually every component that allows for fetching a metrics in Thanos exposes this store API. And in case of sidecar, it is a simple proxy to the Prometheus local data. Let's add another label set, which is like a special label that we allow later on to discover using DNS and Kubernetes services the store APIs in our system. And you will see the power of it later. One more change in the Prometheus configuration itself. We are just changing paths to enable environment variable substitution. And then the main part, which is a Thanos sidecar. So we are adding a simple binary with essentially a thing that exposes the gRPC API. Now we can have a rolling update method because we will have like seamless HA support, so that is doable. And the last change is in the Prometheus configuration itself. It's really important to make sure that each Prometheus, even replica that will scrape the same targets as another one, it is unique. Otherwise, Thanos won't be able to tell like where this data came from. And alerting, we are dropping this special replica label to ensure that we can deduplicate alerts. And that would be it. So let's apply. Let's change this in Europe and the same in US. So let's deploy sidecars here and here. In US, we are adding another replica as well, as you would see. So yeah, they are creating. Now, step number 2. We need some query layer above all those store APIs that are able to query the data. So this is why we are deploying Thanos Querier. But first of all, we are adding a special service I mentioned earlier, which will allow us to do a DNS as a VLOOKUP for Thanos Querier itself. And the main configuration part is here, which is actually you are telling Querier to which data sources, to which store APIs it should have access to. So we are using our nice DNS discovery, and then we are explicitly configuring for US sidecars outside of our cluster, because everything is in EU1, let's say. And that's it. Let's apply Thanos Query as well. Now our Euro cluster is grown, and then let's check. Yep, it seems running. So let's open it up. So actually, Thanos Query exposes similar UI to Prometheus itself. So you can query, you can explore. And as you can see, it's kind of weird, right? We have like 2 metrics only. We are actually querying the same metric as before in Grafana. We only have like 2 clusters, so 2 Prometheus instances. What's going on? So when you turn off the duplication, it will reveal all the replicas that we expect. So as you can see, Thanos kind of seamlessly, transparently deduplicate your data from different replicas based on the label you configure, which is a replica in our case. So when I turn it on, it will try to deduct where are the gaps and substitute the data from the different replica to like smooth the graph. So you can finally rolling restart just fine. So yeah, also useful bit, which is a stores page. So essentially like list of the store APIs we have access to. Cool, but we want to use it in Grafana, right? So step number 3 is to make sure we can actually use it in Grafana, and then actually it simplifies a lot. We just need 1 data source right now, and the same type, which is Prometheus, because Thanos Query exposes the same query API. So when we apply this, we should be able to get the benefits of the Thanos straight away. Now, I'm not using hot reloading in Grafana. I should, but I like when Grafana is stateless, so I can roll it out quickly. Cool. So as you can see, we no longer have like different data sources. We have just only 1, but we have everything under the single query endpoint, which is extremely convenient because now we can actually edit the query and achieve what we wanted before, right? So this is how much Prometheus uses across all the clusters, right? So it's quite convenient. So yeah, that's actually the first phase. So within 3 like simple steps, we have global view and slimness HA kind of solved. So actually, at this point, you can stop if that, if that solves your goals and you don't need, unlimited retention. It's fine to just use it as it is. So yeah, it enables kind of gradual integration if you maybe change your goals at some point. But let's say we want to be, ambitious, and we want to actually see the unlimited, data and make 1 year long queries. One more important thing here before we move is that if you think that your retention is long, I mean, you want only 1 month, which is quite long, you don't really need unlimited retention yet, right? 1 month is like super. Prometheus is enough to kind of store that amount of data. Actually, I met a person at FOSDEM who has 5 years retention with a single Prometheus server and 2 terabytes of SSD, which is insane. And actually, another one. You have as well. Another one. And actually, he did that after my talk when I say that this is insane, but actually, it's doable. But again, like I don't want to manually do the backups, resize of those huge SSDs. And so that's why unlimited retention in form of kind of Thanos might make sense for you. So to start, we need some object storage. So some storage, we want to store our metrics. And you should probably grab something off the shelf, like GCS, AWS S3. But for demo purposes, we start a local menu, which is essentially S3 API object storage. So I will create that one. And after it is created, I should be able to add a bucket. Nice. And now let's see how the step number 4 looks like. So making sure that Sidecar backs up the metrics. So what we need to change is essentially, wow, quite long. Essentially this. So for Prometheus side, we need to disable the compaction because local compaction, will be conflicting with the global one we will deploy later. And then for Sidecar itself, we need to just point to the object storage you want, and that's actually it. So let's apply this in U1, US1, and probably it will take some time to synchronize them. So essentially what is happening right now is that Sidecar now can back up the metrics itself, and it does it by just watching the file system for TSDB or like Prometheus putting the block together in a 2-hour kind of blocks. And every 2 hours, when the block is there, Sidecar will actually upload this immediately to the object storage. So this is important because it's still important to access those Prometheuses for just the fresh data, like 2 hours. But rest should be in the object storage. So let's see. Wow, OK, that was quick. We have a couple of blocks there. We can get into the one of the block, and clearly you can see it's like at the same TSDB block format Prometheus uses. Step number 5, we need to add a compactor because we disabled the local compaction and we don't want small 2 hours blocks laying around. Now, when this is up, step 6 is required. So we want to have a component that allows you to browse those old metrics from the object storage. That's why we created a Thanos store gateway. Let's look around. This is simple stateful set that again has some access to object storage. Let's create this. And now, once this is up, actually, before moving forward, when I would run the Thanos query or Grafana, you will not notice any difference because right now we would have data in our Prometheus servers and in old object storage. So they will be overlapping, but you will see the same lines. But that's why what I did right now is I introduced the incident, the outage. So let's say US cluster is down. And I kind of mimicked it by deleting the stateful set, so deleting the Prometheus from the US cluster. And at this point, we no longer have access and nothing is scraping this data. So yeah, we can confirm in US there is nothing. So how that looks like in Thanos query now? Well, okay, we have cluster EU1 only visible. Now when we go further away, we can see that we have still old data. And this is because the old data is stored in object storage. And we can confirm that in the store page as well. You can see that we have two sidecars as we had. We have new store gateway, which is a processor for our old blocks. And then this unknown type thing is that there's two that are missing suddenly. So last kind of bit, because it's extremely important to note, is that let's check if we actually were notified about this. So now I'm starting the alert manager, and you can see that, well, we are kind of blind. We did not notice that the whole cluster is down. Like, what's going on? And this is because we are lacking of meta monitoring here. And there are different solutions, but to do that without kind of Thanos, you probably have some federated Prometheus for that, but Thanos allows you to add quickly meta monitoring, uses Thanos ruler, which is number 7, so last step. So let's see how it works. It essentially introduces a special normal alert that checks if the Prometheus is up on the different clusters. And then when we deploy it and open the UI as well, when this is up, it should notice after some time that Prometheus is down. Yep, pending. And now when we go to Alert Manager, we should be actually notified at some point. Yep, so now with this kind of setup, we will be able to see that, as you can see, cluster EUS is completely down. We don't have any visibility. And if you would remember only one thing from my talk, remember about meta monitoring. So monitoring your monitoring, stack, it is essential, and like it gives you some, it gives you reliability in this case. So yeah, that's all from me. Join our, Thanos community Slack. I will post this slide on Slack itself as well. So you have all the materials. You have a demo, so you can just run it on your laptop and hope it will work, because I added that for Linux only. And also I kind of launched yesterday this kind of scripting library demo thing that I used during this demo. So feel free to use it as well. Thank you.
Thank you very much. We've got some really good questions on the Slack.
That's good.
Let's get started, shall we?
Yes.
I just want to say thank you for that talk. I think that's one of the best, like 100% demo, like command line led talks I've ever seen. Like, just fantastic. Thank you very much.
Thanks. I like it as well.
So, the first question is, can we poll the room for people using Thanos? So, hands up if you're using Thanos. I mean, I've tried it. I'm not using it that much.
Oh, we have like 3,
I was
2?
expecting way more.
Oh yeah, I think 3, 4, yeah.
Okay. I mean, okay, let's move on. So the first question from Anthony is, where can I get one of those cool Thanos T-shirts?
Yeah, it's prototype. We have only 3, but yeah, do you like it? Then yeah, we might consider that.
There's a question about the pros and cons of Thanos v Cortex. So how do you want to do this?
I can do this. So yeah, we have this discussion. So it's clear. I would say this from the simple perspective. Thanos is a bit newer, simpler to deploy. You have gradual kind of deployment. Cortex is more mature. It's designed to sustain nice QPSs, and the query performance and this part is like much better. And so I'm super happy to talk about reusing the parts, so we can actually join forces and like create something nice together. So I would say that's the main points, like single, kind of simple deployment model, and then query performance and caching improvements, and further plans to improve it even better is so much better at Cortex. So I would say this is, the simplest view.
Thank you. That's very kind. I think, the thing that I know you didn't ask about Loki, but the thing we tried to do with Loki was really inspired by what Bartek did with Thanos.
You mean the name?
Well, not just the name. Yeah, we're both massive Marvel fans, but also like the getting started journey and the incremental adoption and the ability to develop on a laptop. That's where that inspiration came from. I think they just absolutely nailed that with Thanos, and we got that bit wrong with Cortex. And I'm hoping that we can join forces and share and learn a bit more from each other. And I really enjoyed what I have, the bits I have worked with Bartek and everyone. So
cool.
So there's more similarities than differences.
Yeah.
So the next question is, sorry, my phone locked. What's the biggest known installation of Thanos? How can you talk about scale?
So I'm really afraid of talking about this because I'm not a lawyer. So I'm not sure, what I can say, what not. But from what so again, I want to fix this situation. So we want to ship kind of the reference page, and I think it's a super nice idea for Prometheus itself. So you have a special page with reference architecture. You might have a template for that, and we in the next kind of month for sure we'll ship a blog post and kind of the first reference architecture from Improbable itself for Thanos, and then you would have because it's flexible, so you would like to have the information who is using, like what's the load, how much what's the architecture, what underlying Kubernetes solution, or is it Kubernetes? Anyway, and then I will be freely able to talk about it. But I think maybe at Improbable we have 20-something clusters in production. And then each one has HIA Prometheus to kind of monitor those. So you already have like almost 50 Prometheus instances, and then all is served with Thanos. Each Prometheus, I could talk about details, but we have I think it's that's the biggest.
I mean, the scale is quite impressive that they run it at Improbable. There's some questions about how long can it be stored and things like that. We'll skip over there, a bit detailed. I want to go for the more controversial ones.
Yes.
So will Thanos outgrow Improbable as a company? What are the plans for the project?
That's a good question, because...
That's from Anthony. It's not a plant from me.
Yeah, don't worry. No, I mean, we would love to do the same path as Cortex did with joining CNCF. I have no idea how to do it, but I would definitely try to apply in the same manner. And basically, we want to build self-dependent team from different companies. We already have kind of idea who will be the next external contributor, but definitely we want to push it to community. That's the point, right? We don't earn money from this. This is our tool that we solve our internal problems. So why would we keep it, I don't know, secret and over the hand? I don't know. Yeah,
no, I think that's great. I'm going to do two more because I think this is fantastic. Brian asks, what are the performance impacts of queries that have to hit S3?
I would say, so we did a lot of improvements to make it as efficient as possible. I think the initial problem was that we are hitting rate limits and things like that. So when you do query, it actually does a very neat kind of merging of different series posting together into one single request to make it super efficient. So in theory, you should have the same flow, especially with the cache we have on the store gateway layer. You essentially have kind of everything on the file system like Prometheus does, and portions in the memory. So if you query the same data over time, it should be cached as well. So it should be no impact. But yeah, lots of area. I mean, there is area for improvements as well, for sure.
Yeah, query is one of those things that you You just kind of have to grind away at the long tail to eventually bring it down. It's more, I think, like good long tail performance is more about how much effort you've put into query performance than architectural issues, to be honest.
Yeah, and the flexibility to have, you know, maybe you don't need that much of like query performance. You just have one query and then maybe split into many and have additional caches layers like you have in Cortex. Something that in Thanos would be so awesome, and that's the next plan.
So Sharif asks, does Thanos expose Prometheus metrics to monitor itself?
Yes, and this is really tricky, to be honest. When I was deploying, and our team were kind of working on Thanos, is that we are deploying an infrastructure for metrics, and we want to monitor our deployment as well. And like, if something is wrong, is it the whole metric stack or the application itself? So, but yeah, we use Prometheus everywhere.
Excellent. Thank you so much, Bartek. I really enjoyed that.
Thank you.
Thank you.
It's really good.